The global rate of warming is actively accelerating. We are absorbing heat much faster than the historical record predicts. Carbon dioxide currently makes up 435 parts per million of our atmosphere. It is a highly dilute trace gas. This chart maps radiative forcing against CO2 concentration. According to the physical laws of thermodynamics, CO2 has a logarithmic warming effect. Each additional ton of carbon emitted should theoretically trap less heat than the last. But empirical observations tell a different story. Since 1970, and sharply again after 2014, the actual measured temperature of the planet breaks away from that flattened curve, bending sharply upward. The investigation into this acceleration points toward a discrepancy in the planetary energy budget, a variable that climate physics has traditionally treated as a constant. If the warming is actively accelerating, it suggests that the physical baseline used to project future stability may no longer exist. To understand why a dilute gas drives this acceleration, we have to look at the atmosphere's most abundant greenhouse gas, water vapor, which sits at roughly 4,000 parts per million. This is a vertical cross-section of Earth's atmosphere. Water vapor is heavily concentrated right at the surface, but its density drops exponentially as altitude increases. At the tropopause, the altitude where the air temperature hits -40 degrees Celsius, water vapor is almost completely absent. This is the exact boundary where Earth emits infrared radiation back into space. Carbon dioxide, however, is evenly mixed. It remains a uniform 435 parts per million from the surface straight up through the tropopause. Because carbon dioxide completely dominates this high-altitude emission layer, it acts as the primary control knob for the planet's temperature. Water vapor simply reacts to the heat trapped by the CO2. When human activity injects carbon dioxide into the air, the oceans and land absorb a portion, but roughly 46% of those emissions stay in the atmosphere permanently. This permanent retention means that global temperature increases correlate exactly as a linear function of cumulative historical emissions. The total mass sitting in the atmosphere dictates the baseline temperature. Cutting our annual carbon emissions in half next year does not cool the planet. It simply adds a smaller amount to a permanent growing balance. That growing balance dictates the planetary energy budget, the precise measurement of incoming solar radiation versus outgoing thermal energy. We emit industrial aerosols, and volcanoes emit natural aerosols. These particles reflect sunlight and create a temporary cooling effect of roughly -1.4 watts per square meter, acting as a brake on global heating. The primary cooling mechanism, however, is Earth's albedo. Historically, the planet's clouds, ice, and surfaces reflected exactly 29% of incoming solar radiation back into the vacuum of space. To monitor this equilibrium, we use the CERES satellite network, a highly calibrated system measuring the exact radiant energy hitting the top of our atmosphere. This time series graph plots the last 26 years of CERES satellite data. Earth's global albedo has measurably dropped from 0.29 down to 0.28. A 1% drop in planetary reflectivity means a massive influx of solar radiation fails to bounce back into space. Instead, it penetrates and is absorbed by the Earth system. This breakdown in our planetary mirror is the physical mechanism causing the acceleration of global heating. It is occurring right now, completely independent of any new carbon injected into the sky. If our albedo is degrading and energy absorption is accelerating, atmospheric temperatures should have already spiked violently. They haven't. The global ocean acts as a massive thermal heat sink. It currently absorbs roughly 90% of the Earth's excess thermal energy. The thermodynamic cost of this absorption is profound thermal latency. The heat does not disappear. It is stored deep in the water column. Even if global carbon emissions instantly hit absolute zero today, the oceans will continue to outgas and radiate this trapped thermal energy for decades, and likely centuries. The ocean buffer is a thermal battery. It has permanently locked in our current elevated temperature baseline for multiple human lifetimes. This baseline heat is not evenly distributed. Here is a top-down view of the Pacific Ocean in its normal state. The Walker circulation relies on strong trade winds to drag and pile up warm surface water in the western Pacific, near Indonesia. During an El Niño event, those trade winds weaken. The massive pool of warm water sloshes back eastward toward the Americas, suppressing the cold coastal upwelling. This massive oceanic heat release immediately warms the air above it. The atmosphere maintains a constant relative humidity, meaning the absolute volume of water vapor carried in the air skyrockets. This sudden, massive injection of thermal energy and moisture physically warps the entire atmospheric circulation pattern over the equator. The excess energy generates extreme Rossby waves. The global jet stream is forced into unnatural meanders that stretch deep into the northern and southern hemispheres. When these atmospheric waves pump hot tropical air into higher latitudes, gravity compresses the air mass as it descends. The compression creates crushing, high-pressure heat domes. A localized temperature anomaly in the Pacific acts as a fluid dynamic multiplier. It triggers planetary-scale extreme weather events, projecting the ocean's heat across continents. We can map the probability of these events. This standard bell curve represents historical global temperatures and the probability of extreme weather. Cumulative carbon dioxide and albedo degradation force a physical change, shifting the entire baseline temperature of the planet. But the fluid dynamics of the ocean, specifically the redistribution of heat through El Niño, drastically increase the variance. The area under the extreme edges of the curve grows exponentially. The physical mechanisms of the Earth system are multiplying the frequency and severity of statistical extremes, moving the planet into a state of high-variance instability. These extreme fluid dynamics yield brutal physical consequences on land. Prolonged summer droughts violently shrink and dehydrate clay soils, causing the ground itself to subside. In the winter, the recoil hits. Dehydrated ground cannot absorb moisture, leading to rapid runoff and catastrophic urban flooding. Human infrastructure, our dams, bridges, and power grids, were engineered for the tight, linear climatic tolerances of the 20th century. They were not designed to absorb high-variance fluid dynamics. We are watching rigid systems break. In the Arctic, the melting of permafrost triggers massive subsurface collapses and craters across the tundra. The thermodynamic latency of the oceans and the ongoing degradation of our albedo guarantee that these accelerating baselines are a permanent fixture. The Earth system will not gracefully bend to accommodate human settlement. Unless civilization rapidly re-engineers its foundations to match cumulative physical realities, our infrastructure will fracture. We have built our world on a high-stakes assumption that our industrial momentum is as unsinkable as the steel hulls we once set into the Atlantic. But the elephant in the room has grown too large to ignore, moving out of our private shadows and into the center of our lives. This is the meta-crisis, the tipping point where the stories of endless growth collide with the physical limits of our planet. The Lifeboat mini-course is your immediate, structured transition, a free 5-day journey delivered to your inbox to transform global anxiety into local resilience. Day 1 begins with an audit of the invisible, the energy and water systems you rely on every hour, yet rarely ever see. Day 2 forces a change in your geographical lens, challenging you to locate your true home within your watershed and local bioregion. You won't navigate this terrain alone. You will receive daily study guides and synthesized patterns designed to cut through the noise and reveal the architecture of change. Day 3 asks you to practice active hope in a world facing ecological overshoot. Day 4 introduces the demanding standard of revolutionary love. By tracing the water back to your neighbor's tap, you move beyond the narrow walls of self-help and into the expansive, interconnected practice of systems health. The climax arrives on Day 5 with the introduction of a specific framework for your future, the 9x21 harvest. Who is your mutual guiding spirit in this transition, and which 9 things will you choose to do? Stop waiting for the headlines to crush you. Sign up for the Lifeboat mini-course now. Access your Day 1 materials immediately and join the community hub where the next story of our world is already being written. You can remain tied to the illusion of a collapsing global credit card, or take this course to begin building real systems health today. The Earth is tired of the lie. It is time to dance with the truth.